All right, today we are doing a real deep cut into industrial networking. You brought us the specs for the Thor Broadcast F-RSD-A It's a very specific piece of hardware.
It is. It looks niche, but it solves a huge problem.
Okay, so let's unpack that. The core mission of this thing. It seems to be about solving a decades-old issue. How do we get these ancient but super reliable industrial control systems to talk to the modern world of, long-distance fiber optics?
That's it exactly. It's the essential infrastructure bridge.
Yeah.
And what's really fascinating here is just how flexible it is on the old school serial side of things.
When you say multi-serial, what are we talking about?
We're talking about the holy trinity of industrial communication. So RS-232, which is that simple point-to-point standard. Then you have RS-422, and probably most importantly, RS-485.
Right, RS-485 is the backbone for those big control loops, connecting a bunch of devices on a factory floor.
Exactly. So this one little box handles all three.
So you're replacing what might have been 3 different specialized converters. That's a big win for simplicity right there.
It is.
And the main reason, the real motivator to push these protocols onto fiber, it's all about distance.
It's all about distance.
Right.
An RS-485 copper run might, if you're lucky, hit 2,000 feet.
Mm-hmm.
The sources show this can push that same signal. Well, the standard models go to 20 kilometers.
20 kilometers.
And some of the extended versions can go up to 120. That's a revolutionary leap for any kind of centralized control.
You're connecting systems that were just physically impossible to link before.
Precisely. And for that to work, the connection itself has to be solid. It supports both single-mode and multi-mode fiber. And crucially, it can do point bidirectional transmission, often over just a single strand of fiber, which really simplifies the actual installation.
Okay, but this is where I start to see the potential for, massive operational headaches. When you're dealing with older equipment, PLCs, sensors, all that stuff, they all run at different speeds, different baud rates. Wouldn't integrating them require this huge manual configuration mess? Like flipping tiny little DIP switches in a dusty cabinet somewhere?
And that is the exact pain point this thing is designed to eliminate. The real aha feature is its intelligence.
Okay.
It has what they call zero-delay automatic forwarding, so there's no lag, which is critical in a control loop. But the genius part is the automation. It automatically detects the signal baud rate of whatever you plug into it.
From what range?
From a super slow 300 BPs legacy system all the way up to a much faster 115.2 kbps link. It just figures it out.
But the real game changer isn't just detecting the speed once it's set up. What happens if that old machine, cycles its communication speed while it's running?
It adjusts automatically. It adapts to baud rate changes during operation.
Without any interruption.
Without any interruption of service or any need for manual reconfiguration. Think of the time that saves. I remember field engineers having to drive for hours just to troubleshoot a baud rate mismatch. This just takes that problem completely off the table. It's true, set it and forget it tech.
That kind of automation, that level of reliability, it points directly at critical infrastructure. These devices aren't sitting in nice air-conditioned server rooms. They have to survive out in the real world.
Oh, absolutely crucial. Just look at the protection features built in. We're talking 1,500 watts of surge protection.
Wow.
And 15 kV of ESD protection. In an industrial plant, electrical noise and static spikes are a constant threat. This thing is shielded against all of that.
And the environment itself, I was looking at the temperature range, it's staggering. It's operational from -22 to 167 degrees Fahrenheit.
Yeah, that range, -30 to 75 Celsius, means this device can sit unprotected in a desert pipeline control box. Or inside a high-latitude drilling enclosure with no special heating or cooling. It's just built to survive.
So when you put it all together, what does this actually mean for you, the listener? This device is really one of those unsung heroes of industrial modernization. It guarantees you can have stable, long-haul communication for aging, but essential control gear. And it does it by just eliminating all that manual work.
Right. And this raises a really important final question for you to think about. Given that combination, the 120-kilometer range, the dynamic speed adjustment, and that insane temperature tolerance, what kind of infrastructure out there, maybe remote power grids, high-altitude surveillance arrays, or vast railway signaling networks, might completely fail without the silent, specific reliability of a specialized translator just like this one?